Good morning, students. In today's class, we are trying to develop a CNN classifier for the image data set. So, as we already studied that we are using convolution neural network for image classification. So, here we are discussing that how I can build a CNN model on a particular data set which is given in our lab program. Like we want to work with the handwritten visit classification. So we'll build a CNN on handwritten classification, and there is another lab program which says that we have to evaluate the performance of our model, and we have to know about the what is true positive rate, what is false positive rate, antecedent and recall. Okay, so we'll combine these two things and will make us one program which can be used for lab program 6 as well as the lab program 8. So here, to develop a CNN model, we are using a data set with the name MINIST dataset. MINIST is a modified National Institute of Standard and Technology data set, and it's the most popular data set we can say in the field of computer vision. And it is basically used for training the various image processing system, and it can, if you want to start, if anyone want to start the classification of image, they'll always start with the MINIST actually. So when I'm talking about this data set is consisting of around 70,000 grayscale handwritten images, and it consists of the digit from 0 to 9, and total we have a 10 classes, 0 to 9, it will have a total 10 classes, and image is having a size of 28 cross 28 size of image, and the resulting it will make a 784 pixel in total. Okay, and the data is split into the training and testing. So data in training we have taken 60,000 of images, and test we can take 10,000 of images. So it divided into that, and it is a grayscale images. So pixel value will be ranged between 0 to 255. As we know that 0 represents the black, and if we move towards 255, it will represent white. Okay, and we have to these digits, or we can say these images, has to be normalized in a particular range because values are ranging from 0 to 255. So we'll see that how we are doing the normalization of these pixel values. We'll see in the coding part. Okay, and if I'm talking about the label or the classification of the data, and the labels are given from 0 to 9. 0 is means if it is written 0, the label for that is 0. If a digit is written 1, the label will be 1 for that. So this is all about the data set. And in previous classes, we discussed about the confusion matrix. We discussed about how to calculate accuracy, precision, recall, and inference score. We have discussed all these things in our first unit. So if you don't know all these things, please go to that video and listen. Then you will understand that how we can do this. So just I want to give a quick overview that what is true positive rate and true negative rate here. So true positive rate is nothing but it's called a sensitivity, and this is also called a recall. We can say the another name of recall is sensitivity, and which is also called true positive rate. So this metric is basically used to evaluate the performance of the classification model, and this will actually tell me, or it will give the measure the proportion of actual positive values that are correctly identified by models. How many positive values are identified as positive if I want to know the ratio. So I'm using a true positive rate, which is also called recall. So true positive rate can be calculated using true positive divided by true positive plus false negative, which is same like my recall. So this is all about the true positive rate. Now, if I'm talking about the true negative rate, which is also called specificity, okay, this is again used to evaluate the performance of the model. So actually, this measure is used to know that how many actual negative values are correctly identified as negative. So when I'm talking about true positive, how many positive are identified as a positive by the model is called true positive, and how many negative values are correctly identified the model as negative, that is called true negative. The name you can understand. And true negative rate is the formula of true negative rate is true negative divided by true negative plus false positive. Clear? Now, what is true negative? As we know, we have studied confusion matrix. True negative is nothing but the number of correctly identified negative instances. False positive is nothing but the number of incorrectly identified positive instances. Okay, so this is all about the true positive and the true negative. And if we have high negative true negative rate, it means the model have ability to identify a negative as negative. So it will definitely avoid the false positive. When model is saying negative as negative, so definitely I can reduce the false positive rate. Okay, so it can avoid the false positive. That's why if I want to check that my model is identifying negative as negative in what rate, so I can go with the specificity or true negative. Okay. So these all matrices we are using here for check the performance of the model, and our main aim is to develop a CNN model on Venus dataset. So first of all, I have to install the necessary libraries. So I'm installing the necessary library. So I'm using here pip install TensorFlow from scikit-learn. I'm installing all the libraries which are required for me, and then I'm importing the library as earlier what we have done in the previous examples also. So we are importing NumPy, we are importing pandas. I have to split my data into training and testing. So I'm importing train test split. Okay, so if you want to do some pre-processing on your data set, as we are scaling the data, we are trying to scale the data in a particular scale. So I'm using here standard scaler, which is available in sklearn.preprocessing library. Fine. Now I want to evaluate the performance of the model. So I want to draw confusion matrix. I want to know the classification report. You want to know ROC or AUC curve, all these things. So you can import all these libraries, so which is required. Now, if you want to compare the result of CNN with the other classifiers, so you can import those classifier also here. Fine. So this is all about the importing the libraries uh, from the sklearn, okay, or other platforms. So now I'm importing. Now I need a Minus data set. So from the TensorFlow, I'm importing the Minus data set. Fine. And now what I'm doing, as I'm using convolution neural network here, so I have to import the dense layer. As you, if you remember that what are the different layers are available in the CNN. So CNN will have convolution layer, max pooling layer, flatten layer, and dense layer. So I have to import all these layers from the TensorFlow. And as I'm dividing the data into different categories, so I'm importing the categorical. Okay, so these are the all libraries which we are importing. Now I have to load my data set. So I'm loading my data set and I'm dividing my data set into train and test. Fine. So we have loaded the data set and we divided into data into training and training and testing. Now, I told you that image, as it is an image and it is a grayscale image, the image, the pixel value will range from 0 to 255. Now, I want to normalize the pixel value between 0 to 1. Okay, I want to normalize, I want to make it in a scale of 0 to 1. So, what I have to do? I have to divide my train and test images by 255. So, definitely it will come into the scale of 0 to 1. So I have normalized my data from 0 to 1 scale. Earlier it was 0 to 255, now it became 0 to 1. Now, if some of the images, suppose you have a data set where an image is of a different size, some images are available of size of 28 cross 28, some are available of 30 cross 36 cross 36. So you cannot give different size of images to the CNN. So you have to make all images in the same size or same shape. So what I'm doing, I'm using for train data as well as for the test data, I'm making my all data, all images in the size of 28 cross 28. Okay, so we have done this. We have made all the images of size 28 cross 28. Fine, and this one is representing that it is a grayscale image. Now what we are doing here, as my data is having a label in the form of text like 1 2 3 like this, so I want to do, I have to apply one hot encoding. One hot encoding is a method which is used to convert the categorical data into number formats. I have the labels in the form of text. It is written like 1 2 3 4 0, so I have to convert into terms of numbers. I want in terms of number like 0 1 2 3. So I have to apply here one hot encoding, which is convert the categorical data into the numerical format, and it creates one binary column for each category in that particular variable, where one indicate the presence of that particular category and zero will indicate otherwise, means it does not belong to that particular category. So I'm applying one hot encoding for train as well as for the test data and I'm storing result again back to the same variable. Okay, so we have done a little pre-processing here before building a model. So we have normalized my data in the scale of 0 to 1. If images are of different size, we have converted into the same size, and I have converted the categorical data into numerical data. So this is all about the pre-processing which we have done on my image data set. Clear? Now I have to build a CNN model. So I have to build a CNN model. So I'm building a sequential CNN model. So where I know this that CNN model will have multiple convolution and max pooling layer combination of max pooling and convolution layer. So in this we are using two convolution layer and two max pooling layer. So at the convolution layer I'm using 32 filters of size 3 cross 3. Okay, my kernel size is 3 cross 3. I hope you know what is kernel, what is window here. If you don't know, please check the videos of CNN, then you go through with this, so it will be easy for you to understand. Okay, so we are using here convolution layer with 32 filters of size 3 cross 3, and I'm applying a activation function which is ReLU activation function and on the size of input image which is 28 cross 28, and we have written here 1 because it is a grayscale image. If it is a colored image, this value would have 3. Clear? So we applied the first convolution layer. After convolution layer, I'm applying the max pooling layer here. So I'm calling this max pooling, and the window size or a kernel size I'm using here 2 cross 2. Fine. So after max pooling, we are using another convolution layer with 64 filters of size 3 cross 3, and again I'm using ReLU activation function. After this, we are applying again max pooling layer with size of 2 cross 2. After a different combination of convolution and max pooling layer, you have to flatten your data. So see here, you can apply multiple convolution layer and multiple max pooling layer. You can try here, you can apply different size of filters. You can use here different number of filters. At the place of 32, you can use 64, 128, whatever your choice. You can use a different permutation and combination, and you can see the results. You can change the kernel size also. You can change the activation function also. So these are the hyperparameters which we can change. These are the some hyperparameter which we can tweak or which we can tune. Okay, so you can change number of convolution layer, you can change number of max pooling layer, you can change the size of the kernel, you can change the number of the kernels also. Okay, so I am suggesting you people, you do these changes and try to get the results. Okay, so this is the combination of all convolution and max pooling. So after applying two convolution and two max pooling, I want to flatten my data because my data is available in the form of 2 cross 2 in the form of matrix. Now I want the data into the form of vector. So I have to flatten my data. So to flatten my data, I'm using a flatten layer. After flattening the data, I'm giving to the dense layer and I'm using the activation function again, value activation function. And finally, I'm giving my data for the classification. And for classification purpose, I'm using here softmax classifier and I'm expecting the maximum outcome or maximum outcome neurons will be 10 because my data is having 10 classes from 0 to 9. So the final outcome will have only 10 neurons, and as it is a multi-class classification, we are using here softmax. If you have a binary classification, you can use here sigmoid. So softmax is used for multi-class classification. So with this, we have built a CNN model. With this code, we have built a CNN model. I hope it is clear to you. Now, after building a CNN model, I want to compile my model. So to compile my model, I am using here optimizer, which is an Adam optimizer. So we have discussed about the different optimizer functions. So we are using here Adam optimizer. You can use SGD, you can use momentum based optimizer also. It's your choice. We are using here Adam optimizer, and we are using a loss function which is categorical cross entropy loss function, and we are applying this for accuracy. Okay, so we have compiled the model, and then finally I'm training my model, or we can say I'm fitting my model on my data set. So to fit my model, I'm using data and their corresponding label, and I'm using the epoch size 10, batch size 128, and validation split is 0.2. So I hope you people know what is epoch and what is batch size. So see, we have a 70,000 images at a time. In the training, we are taking approximately 60,000 images. So I cannot give all 60,000 images at a time to the model. So what we are doing, we are giving the images in the form of batch. Means all 60,000 images are divided into number of batches. Fine. So we have a total batch of size 128. And once you will give whole data to the model, once your model has been trained on whole data set, then we will call it as one epoch. Okay. So if you want to do a more training on your data model, if you want, see within one epoch, once you are giving your data to the model, model will learn some of the features, not all the features. Now I want that model has to learn most of the features which are available in the data set. So I have to do the training again and again. So for that we are using epochs. So epochs will confirm that how many times you are giving the same data to the model. So one epoch means the model has been trained on your whole data set at least one. 10 epochs means your model has been trained on your whole data set 10 times. So we have to execute all the epochs. So you can change, these are also hyperparameters which you can change here. So, and we are using here validation split which is 0.2. So you can change all these hyperparameters, it's your choice. So you can see here, we can see here that loss, it's showing me loss and accuracy. So you can see here your loss has to decrease after certain epochs and your accuracy must increase after certain epochs. So you can see the comparative analysis between the training loss and training accuracy and between the validation loss and the validation accuracy. So after certain point of time, you can see your loss has been decreased. It was around 0.23 in the beginning and at the last it is 0.0076 loss has been decreased, and in the beginning your accuracy was around 0.93 and at last epoch it is 0.99. So you can see here with the number of epochs execution your loss is decreasing and your accuracy is increasing. It means model have learned most of the features. Okay, the same way you can check the validation loss and the validation accuracy also. So you can see here the validation loss also decreased and validation accuracy also increased after 10 epochs. It is 0.99. It means model have learned properly. Clear? Now, after the learning, after the training and validation, now I want to evaluate the performance of my model on test data. I want to know how well my model have learned from the data set. So to check this, as we know that to evaluate the performance of the model on test data set, I'm using test data. Okay, I'm evaluating the performance of the model on test data. So we are evaluating performance of the model on X test and the Y test. And for checking the performance, we are using the matrix which is accuracy. And I want asking model to predict the label on my test data. Okay, so I'm just giving the image and my model should tell me it is a 0 or 1 or 2 or 3. So just I'm giving the data, model has to predict and the prediction results are stored in y underscore predict dot underscore CNN. Okay, now when I'm doing this prediction, when I'm performing this prediction, I'm using this X test, which is my model results. I'm saying that I'm giving this data, it has to predict and it has to store the result into the y underscore predict dot underscore CNN. So it is y underscore predict underscore CNN is nothing but it is 2D array where each row will contains the model predicted probability of every class. Clear? Now, what I'm doing here with this particular line, y underscore predict underscore CNN underscore label equal to this. What I'm doing here, I'm using a np dot argument max. So this particular line of code is used to get the index of the highest probability in each row. Okay, of y underscore predict underscore CNN and with which is the correspond to the predicted class label. So this will convert the probabilistic prediction into the discrete class labels. And finally, we are converting true label to the label format using this particular line of code. Clear? So this particular line of code will convert the true label from a one-hot encoding format back to a single class label for finding the index 1 as 1, 2 as 2. In this way, we are predicting the label of the model. And finally, I want to I want to display the classification report of my model. So to display the classification report of my model, I want actual label and the predicted label. So I'm using that. And finally, I'm displaying the accuracy of my model, which is 0.99, and the loss is 0.02 here. And I'm displaying the classification report, so which is showing a precision recall F1 score and support for all the classes from 0 to 9, and I'm getting the accuracy, macro average, and weighted average also. So we are displaying the whole classification report here. The same way, if I want to plot the confusion matrix, we can plot the confusion matrix, and you can see this is showing the confusion matrix of my model, of my CNN model. It's showing me, so there is no wrong classification happened here. Everything has been predicted properly. There is no wrong classification. There is no true negative, and there is no false positive and false negative value. Everything is predicted properly. Now, if you want to compare a performance of CNN with other machine learning models, you can do that also. You know that how to develop logistic regression, random forest, and SVM classifier. You can use those model and you can compare the performance of these model with CNN, and you can see that how CNN is better than these models on this particular data set. So you can see here we have flattened the data first. We are flattening the data, training data, and the test data we have flattened. And finally, we are giving the flattened data to logistic regression, random forest classifier, and SVM classifier. And finally, we are displaying the classification report. So this is the classification report which we are getting from logistic, random forest, and SVM classifier. And you can see that your CNN performance, or you can compare the performance of CNN with other machine learning models. So this is all about handwritten visit prediction using CNN. Okay, so this is all about your program. I hope it is clear to you. Thank you.